Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. To factor this binomial, let's go back to our guide earlier. We need to start first with the common monomial factoring, and whatever be the result or a portion of the result, and if it's a binomial, trinomial, or multinomial, we proceed with the next possible scenarios. So let's start again with the common monomial factoring. For common monomial factoring, we are going to check whether there is a greatest common factor aside from 1 for the numerical coefficients, and if there are common variables for each term for the literal coefficients. For our numerical coefficient is 49 and 25. If we're going to look at this and investigate it further, we know that 49 and 25 doesn't have any other common factor or greatest common factor aside from 1. And 1 doesn't make our task easier because it will just be retained as they are. So we skip that one. So in short, there's no common factor here for the numerical coefficient aside from 1. And if we're going to look closer at our variables, c to the power of 8 and f to the power of 10, both terms doesn't have any common or same variable between them. In short, generally, the first step, common monomial factoring, is no longer possible here. And with that, we proceed to the next step automatically. It doesn't mean that if we cannot factor it with common monomial factoring and then we stop, because we're going to move further. Since this is a binomial, there are 4 different scenarios. The first scenario is whether this is a difference of 2 squares, whether it's a difference of 2 cubes. The next is the sum of 2 cubes, to which I believe automatically is disqualified, because when you say sum, it should be plus, but since this is subtraction, so it already automatically disqualified. And of course, for the last, if we cannot move to the difference of 2 squares or difference of 2 cubes, we write this as it is. In short, there's no factor. So let's talk about difference of 2 squares first. 49, being the numerical coefficient of the first term, is a perfect square. It's not a perfect cube. In short, the second condition, difference of 2 cubes, is also disqualified. We are left with difference of 2 squares and the idea as it is. 25 is also a perfect square. So both numerical coefficients fit that standard. Now let's go to our literal coefficients. C to the power of 8 and f to the power of 10, both exponents are even numbers. And if the exponents are even numbers, automatically they are perfect square. In short, this entire polynomial, this binomial, is a difference of 2 squares. And when we factor out difference of 2 squares, we have 2 binomial factors. And these binomial factors are only differ with the operations separating the 2 terms. Of course, you could interchange plus and minus because the factors are under multiplication, so it doesn't matter which comes first. So again, we are already sure this is a difference of 2 squares. Then we can move further. When we factor out difference of 2 squares, we just simply need to look at the first term, take its square root, and the result will be placed as the first terms of both binomials. We're talking about this. Square root of 49 is 7. So place 7 here, place 7 here as well. And for our literal coefficients, c to the power of 8, this is actually c to the power of 4, or the square of c to the power of 4. This would mean the square root of c to the power of 8 is c to the power of 4. Place it here as well. That's for the first term. The second term, okay, 25 or negative 25, but since the negative was already taken charge with the signs, let's focus on the 25. Square root of 25 is 5. So 5 here as well. F to the power of 10 can be written as, f to the power of 5 raised to 2. Okay. In short, the square root of f to the power of 10 is f to the power of 5. Right here, this as well. Now, if you're not convinced with this, you could always try to use the FOIL method. 7 c to the power of 4 times 7 to the c to the power of 4, that's 49, and then add the exponent c to the power of 8. We achieved the first term. We'll have this here. Negative 5 times 7 is negative 35. So it's negative 35 c to the power of 4 f to the power of 5. And then when you're ready to multiply this, that's positive 35. 7 times 5 is positive 35. C to the power of 4, f to the power of 5. In short, these two are cancelled out. That becomes 0. And finally, for the last, negative 5 times positive 5 is negative 25. And you have f to the power of 5, f to the power of 5, add the exponents, f to the power of 10. So this is also a checking whether our factors are correct or not. But since we're just looking for factors, this here are the two factors for this given binomial that is considered as a difference of two squares. The next factor we're looking for is for our next subscriber. Subscribe now!